Last year, global climate trends crossed a line we spent decades hoping to avoid. 2024 served as a sobering realization of what a warmed planet actually feels like. This animated chart illustrates the moment we crossed the 1.5-degree mark above the pre-industrial average. For the first time in history, we exceeded that limit over a full 12-month period. Prominent scientists now warn that 2024 represents a starting point for an even steeper climb. Current data projects that 2026 will overtake 2024 as the hottest year on record, with the atmospheric momentum likely pushing 2027 even higher. The heat limit we once treated as a ceiling is becoming our new floor. To understand why, we have to look at the specific physics driving this acceleration. This escalation is the result of a simple addition problem. The first variable is the heat we've already locked into the system through human-driven emissions. The second variable is a natural climate phase currently beginning in the Pacific, El Niño. This map shows the origin point. El Niño starts with a massive accumulation of warm water across the central and eastern Pacific Ocean. That warm water expands across the equator, functioning as a massive thermal engine that gradually releases energy into the global atmosphere. This sea surface temperature chart shows that engine in action. The dark red bands dominating the center of the Pacific indicate sea surface temperatures well above normal. Eventually, the ocean vents this stored heat upward, raising temperatures across the entire planet. Earth is currently fueling two separate thermal systems simultaneously, one human-made and one natural. Ocean monitoring suggests this specific phase differs from the standard weather patterns of the past. Current models project a super El Niño, where the thermal energy in the Pacific expands and intensifies at an accelerated rate. If these projections hold, we may be witnessing the strongest El Niño ever recorded. This diagram shows the additive equation in action. By stacking this thermal energy directly on the elevated climate baseline, the total temperature pushes violently upward. Adding a natural multiplier to an extreme baseline makes a shattered global record a mathematical certainty. The projected heat for the coming years stems directly from the convergence of these two thermal engines. If this ocean warming starts today, it raises a question about the timeline. Why are the biggest records predicted for 2026 and 2027? It comes down to the lag effect. Because the Pacific holds such a massive volume of water, it takes significant time for that thermal energy to fully transfer into the global atmosphere. As that heat steadily vents outward, 2026 is projected to be the year the atmospheric temperature is pushed into record territory. 2027 marks the culmination of the cycle, the point where the full force of the super El Niño is felt globally. These natural cycles can no longer be evaluated as isolated weather events. They are now operating on a surface that is already dangerously warm. The records of 2026 and 2027 reflect the collision of a hypercharged natural cycle with a human-warmed world.